Assalamualaikum and hello. I, Muhammad Amir Haris bin Muhammad Abu Bakar with matrix number AA200757. Today, my group will present about group project fluid mechanic, which is Raft House. For the introduction, what is flood? Flood is an overflow of water that submerges land that is usually dry. This is happen because of the climate change and dam or leaves break. Our neighbor country, which is Thailand, has already run this project since 2011. This project used the concept of buoyancy to keep the raft house floating. Then, the purpose of this project is to save important document and for the survival. This raft house also intended to become relaxing hut during the non-flood season.
Hi, my name is Muhammad Hazim Mizainuddin with number matrix AA200127, and I will discuss about research background. Buoyancy is a concept that we choose to ensure that the raft house built is able to float in the water during floods. The idea of buoyancy is applied to create a raft house that can float when a flood happens. As we know, Archimedes' principle is the physical law of buoyancy says that a force, an upward or buoyant force, will impact anyone who is fully or partially submerged in a fluid. This force has a value equal to the weight of the fluid that the body has displaced. In this case, the object's weight is its apparent weight, which is never the same as actual weight. When the object's apparent weight is zero, it will float on the fluid and appear to have no weight. When the buoyant force an object experiences equal to the weight of the object, it is considered to be in balance. For the walls of the raft house, we choose the most suitable wood, which is cedar wood. Why we choose cedar wood? This is because cedar wood is one of the best water-resistant wood. Other than that, cedar wood is more durable than many other woods and has a relatively high compressive and bending strength. Cedar wood has dimensionally stability and can be used in construction, flooring, and furniture. So for the roof, we highly choose zinc. This is because zinc is a material that has good heat transfer and corrosion resistance. The characteristic of zinc will efficiently absorb heat from sunlight and also efficiently release it down into the living space. To make sure that the raft house afloat, we have decided to use expanded polystyrene, or we call it as EPS, as a material that can float due its characteristic and properties in line, which is the concept of buoyancy. Expanded polystyrene, or EPS, geofoam is a super lightweight that have density of this material is about 1% of the density of soil. Other than that, we choose EPS because of its moisture and water resistant. The material does not absorb certain substance when exposed to them, maintaining its capacity to function as an insulator. To make it bigger, EPF foam that floats is used because of its capability to hold up a huge mass values produced by raft house. EPS can support a lot more weight due to the excessive weight of the floating structure.
In the methodology, we have three parts, which is lower structure load, upper structure load, and the total of weight structure load. First, for the lower structure load, we have a floating deck, which is it made of oak wood and have a size of 70 square feet and have a thickness of 2 inches. And for the weight of this platform, only 560 kilogram. Next, we move to upper structure load. We have lift load, and we can put 2 people in the raft house with the weight of 70 kg for the assumption, and the total lift load will be 140 kg. In the upper structure load, we have household items load. We have 12 items in this raft house, which is generator, refrigerator, television, stove, safety box, cabinet, fuel tank, mattress, cooking utensils, first aid kit, and extension wire, which is all of these items weight only 900 kg. Lastly, for the methodology, we have the total weight of Raft house structure. First, for the platform, we got 560, and plus by the total weight of lift load, which is 140, and plus by the total household item 900, and for the last one is the structure load of the Raft house, such as door, window, or anything. We got 1093.28, and this was okay. For the analysis and calculation, we use the formula of Archimedes principle, which is M loading equal to density multiplied by area of submerged and submerged height, and will be subtract with the total mass of floating material. Okay, for the floating agent, we use the dog float box, which is have a weight 15 kg per pieces, and length 1.22 meter, width 0.61 meter, height 0.41 meter, and we use 32 pieces of floating box, and this box have water-like product, lifespan 20 years, and have crack resistance. Okay, this is some example calculation that we have made. First, for the submerged area, we have calculate the area that will be submerged into the water, and we got the area for submerged is 23.81 square, and for the height, we got for the submerged height we got 0.205 meter, and for the total mass of floating material, we got 491.96 kg. Okay, this is the maximum capacity that cannot be exceeded by the Raft house, to make sure it is safe to float on the water. For the freshwater, the maximum load capacity that can be used is 4,389.09 kg, and for the seawater, the maximum capacity is 4,504.28 kg.
Hello, my name is Amir Azim bin Azmi with metric number AA200257. So I will present for the next part, that is project design. For our Raft house, it had two parts, that is Raft house structure and floating deck. For Raft house, the dimension is 120 multiple by 120 multiple by 75 inch, and floating deck dimension is 204 multiple by 204 multiple by 9.25 inch. Then house plan. As we can see at the left side, this is our house plan that we planning to put the household item. Finally, list of building material. For this list, it had 8 parts, which is house floor, wall, roof truss, roof panel, window, hollow wood door, floating deck, and EPS float deck. And the total mass of this Raft house is roughly about 1,653.28 kg. Okay, for the discussion, based from the analysis and calculation, 32 piece of floating board is used to support the Raft house and household item to prevent it from sink. By using Archimedes principle formula, we can state the buoyant force or upward force on a fluid is equal to the weight of this piece of fluid. In this project, the displace of the fluid is determined by the Raft house with household item that push out a volume of water that make the volume of water and the Raft house is equal. Due to that, the floating board is used because it had high buoyant force to float in the water by using Archimedes principle. From this floating box, we can calculate the total loading that can be supported by the floating box. Then, based on analysis and calculation, we can discuss that the floating box can support loading around 4,389.9 kg for freshwater and 4,504.28 kg for seawater. So if the loading is adding exceed the amount of loading capacity that can be support, the raft house will be easy to sink. To find the loading capacity after deduct, we deduct the lower structure load, upper load, life load, and household item which loading capacity before deduct. So after we deduct all this information, we get 1695.81 kilogram. So the balance of this loading after deduct is 1695.81 kilogram, shown that raft house can still floating safely. So that's all from me. Thank you.
For the conclusion, every material and measurement taken and calculated is being researched to ensure that the raft house produced can function well and float on the water. The selected household appliances are the result of our discussion where all the tools are basic necessities needed for a person to survive in the event of a flood disaster. After we calculate, the total mass for the raft house will, including household appliances, with a capacity of 3 people is 3,253.28 kg. For that, it is possible to support the weight of the entire raft house constructed in both freshwater and saltwater by employing 32 EPS foam deck float in total. So the fact that this draft house exists shows how beneficial it is for locals to be better prepared for the disaster. This can save valuable goods and items, preventing residents from suffering significant losses. We hope that all the theories and ideas we've learned about fluid mechanics will be put to use and benefits for our community more.